So welcome everybody to this latest video 162 Maths, and in this video we'll be going over the GCSE Maths higher topic of circle theorems. We'll go over quickly what it is you need to revise, and also there's a downloadable link to some notes on circle theorems before going through some exam style questions, which as always can be downloaded by clicking on the link in the description below. Now, before we get started working through some circle theorem questions, it's always good practice to make sure you're fully aware of all the circle theorems in terms of all the rules, the theorems, and also in some aspects how to prove each of these theorems. Now, one thing that is available for you to download is the following revision sheet, which basically covers everything about circles that you need to know that's related to the circle theorems, barring the area and the circumference of a circle. Now, looking at this, and again, so as you can see on the sheet, we've got the 7 main circle theorems, and there are actually 7. We also look at basic rules of angles in triangles, angles on parallel lines is something to look out for, parts of a circle, because obviously there's key properties in terms, particularly the vocabulary that's used in the circle theorems is really important to understand, but also that helps if you know what the parts of the circle actually are. Now, when dealing with circle theorem questions at the start, and if you find this topic particularly difficult, then I strongly recommend that you have all of these theorems in front of you, just like you would have a calculator when you're going through calculator questions, and just refer to them. Now, as a teacher, circle theorems is probably one of the most difficult topics for a teacher to kind of infuse on their students. And the reason for that is, as well as the only thing we can do is show you the circle theorems, what they are, how to prove them, and tell you what to look out for. But ultimately, with most angle questions, it's all going to be about of whether you spot each of these theorems. So if you're confronted with a circle theorem question, can you see an arrowhead? Can you see a triangle inside a semicircle? Can you see a bow? Can you see a cyclic quadrilateral? Can you see tangents? Can you see the alternate segment theorem, etc.? So it's really important that you do familiarize with each of these circle theorems, but also know and how to use each of those. Now, I strongly recommend that you have an attempt at downloading this sheet and having a really good glance if you are finding circle theorems that are a little bit more challenging as a topic. Now, on the sheet, it's quite extensive. It may seem like you've got a lot to revise, but all it covers is generally not only the proof, which can take a while and it's very algebraic, but also taken from past exam questions, what similar questions have been done. So if you can revise everything that's on these 4 sheets, it will hopefully give you better understanding and better grounding to answer circle theorem questions. So again, a copy of the questions that we're about to go through in this topic test are available for you to download simply by click on the link in the description. So let's get started on question 1. So question 1 says the diagram shows a circle with center O, AB is equal to BC, and the line EF is a tangent to the circle at C. And question 1.8 says what is the size of angle ADC? Now, with all these types of questions, it's always really important that you first highlight what it is you've actually got to find. So here we're looking for angle ADC. So it's going from point A to D to C. So it's this angle here that I'm wanting to find. Now, again, looking at this, I can see that AC is the diameter of the circle, and any angle that's opposite the diameter is going to be 90 degrees. So this angle here is going to be 90 degrees. So the option I want to tick is going to be 90. And again, how do I know that? Is because angles opposite the diameter equals 90 degrees. Then for question 1b, it says what is the size of angle ACB? So ACB is this angle here. Well, seeing as ABC is a isosceles triangle, so ABC equals isosceles. And how do I know that? Well, because AB is equal to BC, and that tells us in the information in the question. So then I also know that this angle here is going to be 90 degrees for the same reason as ADC was 90 degrees, because the angle opposite the diameter. So that's 90. So then to work out this angle here, x is going to equal 180 minus 90 divided by 2, because that's also going to be x as well. So then working that out, that gives me an answer of 45 degrees, which again is my third option. Moving on to question 1c, it says work out the size of angle ECD. So if I just go back to the diagram, ECD is this angle here, and if I just label that as question C. Now from this I can see that it's going to be an alternate segment theorem, because here is my triangle with each of those points there, with one of the points being a point on the tangent. So angle ECD is going to be the same as this angle here, so it's going to be 65. So the angle I then need to write is 65 degrees, and I'll just write in the comments alternate segment theorem. Then moving on to question 2, it says AB are points on a circle, and it says PA and PB are tangents. Work out the size of angle APB. So APB is this angle here, and let me just start by calling that X. Now one of the circle theorems is that two tangents that meet at a particular point outside of the circle are going to be equal length. So these two lengths here are going to be equal. So then that means that this angle here is going to be the same as this angle here, which is 68. So therefore then, to work out X, I do 180 minus 68, which gives me an answer of 44 degrees. Now moving on to question 3, it says that CDE are points on a circle. Is X the centre of the circle? And it says yes or no, support your answer for 2 marks. Now for this, the first thing you need to establish is what you're going to use to prove. So if X is at the centre, then X will equal 108 as angles subtended at the centre are twice the size of the angle subtended at the circumference. So in other words, what this is here is just a definition of the arrowhead. But again, remember, you can't write the arrowhead because that's not going to be allowed in the answers. You need to give the proper more formal definition. Now, in terms of this, one fact that I know is that angles around a point equal 360. So X is going to be 360 minus 252, which equals 108 degrees. So as X equals 108 and 54 times 2 equals 108, then X is at the centre. So the answer then is yes. Then moving on to question 4, it says O is the centre of the circle. Work out the size of the obtuse angle of AOC. Clearly state any circle theorem that you use to answer the question. Now for this, there's 2 possible answers you can give. Now I'll probably go through the most common one first. So answer 1 is that opposite angles in a cyclic quadrilateral add up to 180. So angle ABC is going to be 180 minus 118, which gives me an answer of 62 degrees. So this angle here is 62. So then I can then say that angles subtended at the circumference are twice the size of the angle subtended at the centre. Oh, I just forgot those the wrong way around. So let me angle subtended at the centre, subtended at the circumference. So AOC equals 2 times 62, which is 124 degrees. Now another way of doing this is if I take point A and C, and let's say I just move them up here. So this is going to be, let's just call that A dash, and this is going to be C dash. Now from this, I can then have got a arrowhead, which would mean that this angle here is going to be half the size of that angle there. Now regardless of this, this little shape here, which although it may not look like it, is actually an arrowhead. So this shape here is an arrowhead, which therefore means that this angle here is going to be 2 times 118, which is 236. So then I can then work out what this angle here is going to be, which that'll be 360 minus 236, which gives me an answer of 124 also. So again, two different ways, two different sets of circle theorems you can use, but ultimately gives you the same answer of 124. And I don't know why I crossed that out. I'm supposed to highlight it, and I've got rid of the 1, so let me put that back, and there we go. Moving on to question 5, it says that CD is equal to DE, and it says work out the size of angle CDE, state clearly any circle theorems that you have used to answer the question. So let's have a look at this one then. So from this I can see that I've got a bow, so this angle here is also going to be 57. Now in terms of why that's 57, because angles that share the same arc or segment are going to be equal or equal. In other words, we've got the bow. So this angle here is going to be 57. So then as triangle ECD is isosceles, and that's because CD is equal to ED, then angle ECED is also going to be equal to 57. So therefore angle CDE is going to be 180 minus 57 minus 57, which gives me an answer of 66 degrees. Then moving on to question 6, it says O is the centre of the circle. Prove that AOC is 2 lots of x plus y. Now for this I'm going to do it more on the diagram rather than anything else, but hopefully if you want to write down the actual descriptions you can do by putting what I'm saying into words. Now we can see that this side here is, if I just take this triangle here, let me just highlight it in blue, that these two sides are going to be equal because they're both a radius. So AO, so AO equals OB because they are radius of a circle. So therefore triangle AOB is going to be an isosceles triangle. So then this angle here is also going to be x. So OAB is also going to equal x. So therefore, to work out BOA or AOB, that's going to be 180 minus 2x. So that's what this angle here is. And let me just put a little box around that. So then if I repeat what I've just said, but with regards to this triangle here, that as OB equals OC, because they're both a radius of a circle, that triangle OBC is isosceles, if I can spell it just about, and that angle BCO is also going to equal y. So therefore this angle here is going to be 180 minus 2y. So then to work out this angle, because I know that angles around a point add up to 360, so then to work out this green angle, all I've got to do is take away 360 and the blue angle and this orange angle. So angle AOC is going to equal 360 minus the blue angle, which is 180 minus 2x, minus the orange angle, which is 180 minus 2y. Then if I expand the brackets of this, the wind up is 360 minus 180 plus 2x minus 180 plus 2y, and simplifying all of that, the 360 cancels with the subtraction of the two lots of 280, so that then becomes 2x plus 2y, which if I then factorize that gives me 2 lots of x plus y, which is exactly what they wanted me to prove. Then moving on to question 7, it says BD and CD are tangents to the circle with centre O. Prove that OAC is a equilateral triangle. So first things first, let's state the facts. So if OAC is an equilateral triangle, if I can write that a little bit better, then all angles in terms of AOC, OAC and OCA are all going to equal 60 degrees. So let's have a look at working this out. So we know that a tangent meets a radius at 90 degrees. So this angle here is going to be 90, so therefore I can then work out what this angle is going to be by doing 360 minus 60 minus 90 minus 90, which equals 120. So this angle here is 120. I can then work out what this angle here is by doing 180 minus 120, which equals 60 degrees. And the reason for that is because it's on a straight line. So let's put 60 here. Now I also know that AOC, these two lengths are going to be equal, so that means that it's going to be an isosceles triangle, so these two angles are going to be the same. So then taking this triangle out, I know this is 60, this is x, and this is x. Angles in a triangle add up to 180, so 180 minus 60 equals, divided by 2 is going to equal x, and x equals 60. So as AOC equals 60, OAC equals 60, and OCA equals 60, then triangle OAC is equilateral. And so something along those lines would be absolutely fine. Moving on to question 8, it says AC is the diameter of a circle with centre O, line CS is a tangent to the circle, ABT is a straight line, and angle BTS is equal to Y. And for part 8 it says prove that the angle CAB equals Y minus 90, and clearly state any circle theorem you use together with any other angle properties that you use to use in your proof. So angle CAB is this angle here. So let's start by colouring that in. And this is the angle that we then need to work out. Now, let's have a look at what we know. So we've got y, so I had to work out this angle here. That's going to be 180 minus y because it's on a straight line. Now I know that this angle here is going to be 90 degrees. Why? Because tangents meet radiuses at 90 degrees. So then to work out this blue angle, well, if this angle here is 180 minus y, then to work out angle CAB, well, that's going to be 180 minus the purple angle, which is 90, minus the green angle, which is 180 minus y. So then if I simplify this, I get CAB equals, well, 180 take away 90 is 90, and minus 180, and then plus y. Now that then becomes minus 90 plus 9, which if I flip those two things around equals 90 minus y. So CAB equals y minus 90. So then moving on to question 8b, it says you are given that angle ACB is 30 degrees, work out the value of y and you must show you're working out. So first of all, let's mark where ACB is actually going to be. So ACB is this angle here, and this little angle here is 30 degrees. Now from this, if I take that triangle out, so if I just highlight which triangle it is I'm actually looking at, so I'm looking at this triangle here. And let me just do a little sketch of that. That this angle here is 90 degrees because it's the angle opposite the diameter in terms of the semicircle circle theorem. I know that this angle here is 30, so I can then work out what this angle here is going to be. Now that angle there is going to be 180 minus 90 minus 30, which is 60 degrees. So then if I just start by labeling that B, so from this, what I know, if this angle here is 60, now that's angle CAB, so CAB equals 60. Now taking the answer from part A, then we know that CAB is y minus 90. So therefore y must equal, take the 90 over the other side, equals 150, and there is my answer for that one. Then moving on to question 9, which is our last question. It says here is a cyclic quadrilateral. X to y is in the ratio of 8 to 7. Work out the size of angle W. So let's have a look at working through this. Now in terms of turning a ratio into an equation, from this what we know is that if we've got x to y is equal to 8 to 7, then we know that x over y equals 8 over 7. If I cross multiply, I get 7x equals 8y. Now I'm going to leave that for now for the time being. Now what I know is that as it's a cyclic quadrilateral, that x plus y equals 180 as opposite angles in a cyclic quadrilateral add up to 180 degrees. So now if I take this equation here and I make x the subject, so basically x equals 8y over 7. Let me just put a little bubble around that. That if I take this equation here, I combine it with this, then what I end up with, so if I sub x equals 8y over 7 into this, then what I get is 8y over 7 plus y equals 180. Now what I want to do is get rid of this 7, so if I can do that by multiplying everything by 7. So if I multiply this by 7, this by 7 and this by 7, then what I'm going to end up with is 8y, because the 7 and the 7 cancel out, plus 7y equals 180 times 7, which is 1260. Then combining these two things, I get 15y equals 1260. So y equals 1260 divided by 15, which equals 84 degrees. Now the question's asked me to find out what w is. So I know that y equals 84. So then using this, I know that, so we just put a little bubble around that. So I know then x plus y equals 180. So x is going to equal 96. And then once I know what x and y is, so going back to the diagram, this angle here is going to be 96. This angle here is going to be 116. This angle here is going to be 84. And w is what I want. So therefore, if I can then work out that 360 minus 96 minus 116 minus 84 equals w, which then gives me an answer of 64. So the answer then is 64.